Sealing flat cable to wellhead requires careful consideration to prevent water ingress and ensure the longevity of the electrical connections. Several methods can be employed to achieve a reliable waterproof seal. Firstly, a waterproof cable entry gland specifically designed for flat cables can be used. These glands are engineered to compress around the cable, creating a tight seal that prevents water from entering the wellhead. Manufacturers like Hubbell and Appleton offer a variety of these glands, which should be selected based on the dimensions of the flat cable being used. Tighten the glands securely to create a watertight seal around the cable. Secondly, consider using a potting compound. This involves installing a junction box at the wellhead. Feed the flat cable into the junction box and then fill the box with an epoxy or polyurethane potting compound. The potting compound encapsulates the cable connections, creating a solid, waterproof barrier. Ensure the potting compound is compatible with the cable jacket material to prevent any degradation over time. Thirdly, if a standard cable entry gland or connector is not readily available for flat cables, a custom-made connector can be fabricated. An experienced electrician or machinist can create a connector that precisely fits the flat cable and provides a watertight seal. This option may be more expensive but offers a tailored solution for unique installations. Ensure it is a watertight seal and is compatible with the size of your flat cable. Fourthly, a cable gland with an O-ring gasket can be utilized. This method involves modifying the shape of the flat cable to better fit a standard round cable gland. Wrap the flat cable with electrical tape or heat shrink tubing to create a round profile. Insert the cable into the gland and tighten it to compress the O-ring, creating a watertight seal. The electrical tape or heat shrink tubing should be waterproof and resistant to degradation from exposure to water and soil. Fifthly, sealing kits specifically designed for flat cables at wellheads are available. These kits typically include a gland, O-ring, and other components necessary to create a waterproof seal. These kits offer a convenient and comprehensive solution for sealing flat cables and often include detailed instructions for proper installation. When implementing any of these methods, it is crucial to consider several additional factors. Firstly, ensure the wellhead is level. A level wellhead ensures that the cable entry point is at the highest point, minimizing the risk of water pooling around the seal. If the wellhead is not level, water may accumulate and eventually compromise the seal. Secondly, utilize waterproof conduit to extend the cable from the wellhead to a junction box or other device. The conduit provides additional protection for the cable and helps to prevent water from entering the system. Seal the conduit connections with waterproof coppers or sealant to maintain a watertight barrier throughout the entire installation. Thirdly, regularly inspect the seal and tighten connections as needed. Over time, this seal may degrade due to environmental factors, or the connections may loosen due to vibration or temperature changes. Regular inspections and maintenance can help to identify and address any potential problems before they lead to water ingress. When selecting a sealing method, consider the specific environmental conditions at the wellhead. Factors such as temperature, humidity, and the presence of corrosive substances can affect the performance of the seal. Choose materials and methods that are resistant to these factors to ensure long-term reliability. Furthermore, proper installation techniques are essential for achieving a reliable waterproof seal. Follow the manufacturer's instructions carefully and use appropriate tools and equipment. Ensure that all surfaces are clean and dry before applying any sealant or installing any components. Taking these precautions will help to ensure that the seal is properly installed and will provide long-lasting protection against water ingress. In addition to the methods mentioned above, several other considerations can contribute to the overall effectiveness of the sealing system. Firstly, consider the type of cable being used. Flat cables with a robust outer jacket are generally more resistant to water ingress than cables with a thinner or less durable jacket. Select a cable that is specifically designed for submersible applications and that is rated for direct burial in wet environment. Secondly, pay attention to the cable entry point. The entry point should be located in a protected area, away from direct exposure to rain or other sources of water. If possible, consider installing a shroud or other protective cover over the entry point to further reduce the risk of water ingress. Thirdly, use a high-quality sealant. The sealant should be compatible with the cable jacket material and should be resistant to degradation from exposure to water, soil, and other environmental factors. Apply the sealant carefully and ensure that it completely fills any gaps or voids around the cable entry point. Fourthly, consider the use of a pressure test to verify the integrity of the seal. After the sealing system has been installed, a pressure test can be performed to ensure that it is watertight. This involves pressurizing the wellhead and monitoring for any leaks. If any leaks are detected, the sealing system should be repaired or replaced before the well is put into service. In addition to the technical aspects of sealing flat cable at a wellhead, it is also important to consider the applicable codes and regulations. Electrical codes, such as the National Electrical Code, provide specific requirements for wiring in wet locations. Consult with a qualified electrician to ensure that the installation complies with all applicable codes and regulations. Furthermore, local regulations may require permits or inspections for well installations. Check with the local authorities to determine what permits or inspections are required before beginning any work on the well. Proper planning and adherence to codes and regulations will help to ensure that the installation is safe, reliable, and compliant. When working with electrical equipment, always take necessary safety precautions. Firstly, disconnect the power supply before beginning any work on the well. Secondly, wear appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, use insulated tools to prevent electrical shock. Fourthly, follow lockout/tagout procedures to ensure that the power supply remains disconnected while work is in progress. Taking these safety precautions will help to prevent accidents and injuries. In summary, sealing flat cable at a wellhead requires careful planning, proper installation techniques, and the use of appropriate materials. By following the methods and considerations outlined above, it is possible to achieve a reliable waterproof seal that will protect the electrical connections and ensure the long-term performance of the well. Remember to consult with a qualified electrician and to comply with all applicable codes and regulations. Furthermore, regular inspections and maintenance are essential for maintaining the integrity of the seal and preventing water ingress. These practices ensure the safety and reliability of the well system. When selecting a waterproof cable entry gland, consider the specific type of flat cable being used. Different flat cables have different dimensions and shapes, so it is important to choose a gland that is compatible with the cable being used. Some glands are designed for specific types of flat cables, such as those with a rectangular cross-section or those with rounded edges. Refer to the manufacturer's specifications to ensure that the gland is compatible with the cable. In addition to the cable type, also consider the environmental conditions at the wellhead. If the wellhead is exposed to harsh weather conditions, such as extreme temperatures, high humidity, or corrosive substances, choose a gland that is made from a durable material that is resistant to these conditions. Some glands are made from stainless steel, which is resistant to corrosion, while others are made from plastic, which is lightweight and resistant to chemicals. Select a gland that is appropriate for the specific environment in which it will be used. When using a potting compound, it is important to choose a compound that is compatible with the cable jacket material. Some potting compounds can react with certain cable jacket materials, causing them to degrade over time. Refer to the manufacturer's specifications to ensure that the potting compound is compatible with the cable jacket material. In addition to compatibility, also consider the viscosity of the potting compound. A compound that is too viscous may be difficult to pour into the junction box, while a compound that is too thin may leak out of the box before it has had a chance to cure. Choose a compound that has a viscosity that is appropriate for the specific application. When creating a custom-made connector, it is important to ensure that the connector is properly sealed to prevent water ingress. This can be accomplished by using O-rings, gaskets, or other sealing devices. The sealing devices should be made from a material that is compatible with the cable jacket material and that is resistant to degradation from exposure to water and other environmental factors. In addition to the sealing devices, also consider the design of the connector itself. The connector should be designed to provide a tight, secure fit around the cable and to prevent water from entering the connector. This can be accomplished by using a threaded connection or by using a clamping mechanism. When using a cable gland with an O-ring gasket, it is important to ensure that the O-ring is properly sized and installed. An O-ring that is too small may not provide a tight seal, while an O-ring that is too large may be difficult to compress. Refer to the manufacturer's specifications to determine the correct size of O-ring for the specific gland being used. In addition to the O-ring size, also consider the O-ring material. O-rings are available in a variety of materials, each of which has different properties. Choose an O-ring material that is compatible with the cable jacket material and that is resistant to degradation from exposure to water and other environmental factors. When using a sealing kit, it is important to follow the manufacturer's instructions carefully. Sealing kits typically include all of the components necessary to create a waterproof seal, but it is important to install the components correctly in order to ensure that the seal is effective. Refer to the manufacturer's instructions for detailed information on how to install the sealing kit. In addition to the methods mentioned above, there are several other factors that can contribute to the overall effectiveness of the sealing system. Firstly, consider the type of well being used. Different types of wells have different characteristics that can affect the performance of the sealing system. For example, flowing artesian wells, which have positive pressure at the wellhead, may require a different sealing approach than wells that do not have positive pressure. Secondly, consider the depth of the well. The deeper the well, the greater the pressure that the sealing system will need to withstand. Choose materials and methods that are appropriate for the specific depth of the well. Thirdly, consider the quality of the water being produced by the well. Water that is high in minerals or other contaminants can degrade the sealing system over time. Choose materials and methods that are resistant to these contaminants. Fourthly, consider the maintenance schedule for the well. Regular maintenance can help to identify and address any potential problems before they lead to water ingress. Develop a maintenance schedule that includes regular inspections of the sealing system and replacement of any worn or damaged components. Taking these factors into consideration will help to ensure that the sealing system is effective and that the well operates reliably for many years to come.